Okay, so HL mock exam paper 2, going through some of those. Let's go to question 5. Alright, so it's about enclosed region, but it's with respect to y, not x. So we've got some region here. We got some function, it's an x squared plus 2, but they want to get it this region, not what is under the curve normally x-axis. That means you have to do a little bit of rearranging here. So currently our function is this. Okay, so we'll need to integrate it, but we need to rearrange it to integrate it with respect to y, so the inverse. So I need to get x in terms of y, or y in terms of x, and so it'll be square root of y minus 2. So using that now I can integrate square root y minus 2 with respect to y, with respect to the y-axis, which means I need these points here to complete the integral. So in the question, they give the line y equal to 4, so that's probably that one up here. So that will definitely be cutting through the y-axis. So we need to find the other one, but it wouldn't be at 0, it would be at 2, so it would have a y-intercept at 2 due to the plus 2 here. Okay, so we can use a calculator to calculate that and ask for it in significant figures. So that's the expression, and they ask for it in significant figures, so 1.886 for 4 significant figures. Okay, so that's part A. Part B, so we're dealing with rotation through 2 pi, so 1 full 360-degree rotation. So this is a formula. So pi times from 4 to 2, y minus 2 squared dy. Okay, so that's from our formula booklet. Now it says the word exactly here, the exact volume, so you might have to avoid the calculator, you might have to do this one out. So if I square that, it makes it a lot, I'll just do that to squares, which makes it a lot easier. Sorry, what else will happen, wouldn't it? So now we can integrate it. So we get y squared over 2 minus 2y, leave the pi out there, and from 4 to 2. Also then 4 down 2, I think you end up getting 4 squared is 16, 8 minus 4 squared, 8 minus 2, that'll be 4, and 4 take away 2 squared minus 2, 4 take away 2, isn't it? And I think we're left with, when you sub those in, I think we're left with 2y. You can check that yourself, but I think that's how you do that. Okay. So moving on to question number 10, I think that's the one we need to do next. Let's get rid of that. Okay, so question 10. So the sketch, I presume, can be done on a calculator, so I won't need to do that. With reference to your graph, so some kind of bottoming out graph there like that. With reference to your graph, explain why f is a function in the given domain. Well, you can see that each x value has a unique y value, so that's good, pass that test. Part 3 then, explain why f has no inverse in the given domain. Well, it fails the horizontal line test, so if you draw a horizontal line through and it touches twice, then it failed. Okay, so that's all you have to say. Explain why f is not a function for minus 3/4 pi up as far as pi. Okay, so your function is, this is part 4, question 10a. Your function is this, tan x plus y over 4 cot, not cos, cot pi over 4 minus x. Okay, So if we were to sub in negative 3 pi over 4, we get pi over 2 here for tan, which of course is undefined. It would be 90 degrees, so it's undefined. And the same for pi over 4. So you could say something like, if you just subbed in, it wouldn't give a valid answer, or tan pi over 2 is undefined and therefore it is not a function. Okay. Part B then. So gt tan x is called t. So I want to transfer the current function into a function where it's just in t, and t is equal to tan x. All right. So it requires manipulation of that to look like what they want the answer to be. Gt is 1 plus t all to be squared, and minus t all to be squared, and that t is tan x. Okay, so we need to rearrange this. Okay, well, cot, it's going to be 1 over tan, isn't it? So we've got tan, so the function could be rewritten tan x plus pi over 4, all divided by tan, instead of multiplying by cot, we can divide by tan, same. Alright, then we use some of our compound angles, so angles added together. Tan works, so from your formula book, tan works a little bit interestingly. It's not like sine and cos for these. So this first one will equal tan x plus tan pi over 4. So we did an example with this already in class. Minus tan x tan pi over 4 taken directly from the tables. You're looking at these tans. And then the other one is minus, so you need to switch some signs. Now it'll be pi over 4 first on this, because that is pi over 4. And now we're doing minus tan x all over 1 plus tan pi over 4 tan x. So go to your formula booklet if you're not sure where that came from. And you should see that it is there. Okay, but that's not us done. Sorry, just get the form booklet. That's not us done. We need to get in this form, which is going to be tricky. But we can just keep the first fraction, change signs to multiply, and then things will start happening. So let's change these to t's. Let's change the tan pi over 4s to 1s. Alright, so that'll be t plus 1 all over 1 minus, so that would be tan x, that's just t, and that's 1, so that's t. Okay, multiplied by, flip this, 1 plus, well that's 1, and that's t, this is 1 minus t, 1 minus t, and all of a sudden we see that it looks exactly like we wanted to. That would be 1 plus t squared over 1 minus t by itself as well. Okay, so that's how we do that. Alright, so part C then is from the calculator. You are asked to sketch, including asymptotes and any intercepts. So from calculator, it should look something like that. This is our t-axis, this is our y-axis, and you got an asymptote here, and that's y equals 1. I should have done that dotted line. Okay. Okay, so there's our asymptote, something like that. What else do we need? Okay, so that's taken from the calculator. Part D. Let alpha and beta be the roots of this function equal to k. So this equal to k, this equal to k. Alright, so let's make that equal to k. T part 1. 1 plus t, 1 minus t squared equal to k. Okay, that's done. And find A and B, alpha and beta in terms of K. And K is between 0 and 1, which comes up later in the question. Okay. So, well, let's expand this and see, can we just get the roots? Okay. Maybe another way to do this, but I'm just going to square the top here, so I get 1 plus 2t plus t squared. That's all going to be multiplied by this squared, so that's 1 times k, so that's minus 2kt, and then plus k squared t. Okay, so let's gather like terms, so it's not k squared, it's t squared. Let's gather some like terms to form a quadratic. Looks like there's going to be quadratics. So the t squareds are together, so t squared here has a 1, over here has a negative k with it, plus the t's, this one has a 2, this one will be positive 2k, and then we're left with 1, take away k, and that equals 0. So here is our quadratic. Now use the quadratic formula to finish, and you should get the roots, alpha and beta. So this would be A, B, C. If you do that, I'm not going to do it here because it will take a while, but I'm sure you can do it. You'd end up with k plus 1 plus or minus 2 times root k all over k minus 1. Okay, so if you're not sure how to do that one, I can do it again for you, but that's just a quadratic formula, so we can tidy it up. Alright. Part 2 then, show that alpha plus beta is less than minus 2. Now the key bit of information has been given at the start of that, and that's k is between 0 and 1. Now, this is alpha and beta, one with plus, one with minus. So let's add them together. K plus 2 root k all over k minus 1. Alpha plus beta. So we're looking at alpha plus beta, and prove that show that is equal to minus 2. Okay, so I'm going to plus these two together. So imagine that was alpha with the plus. Now minus, so k plus 1, and here's the minus 1. We want to show that that is less than minus 2. It doesn't look like we can be sure yet. Common denominator. The 2k is going to cancel each other out here, and we're going to be left with 2 times k plus 1. And is that less than minus 2? Now, k is a fraction, and that's the key here. K is a fraction, which means k plus 1 is going to be greater than k minus 1. This is going to be a negative value then. So k minus 1 is going to be definitely a negative fraction, because that's going to be a fraction, which is going to increase the negativity almost above the top part, and that's already going to be times 2, so it's going to be quite, it's going to be bigger than 2, because it's adding on a bit of a fraction, and this is positive. So saying that somehow would show that, so some version of that. Okay. Okay, I'm going to stop now and I'll do the other solution.